Have you ever been outside at night, looked up, and just caught that flash, that brilliant, super fast streak of a shooting star? It's an incredible moment. But what if I told you there's another way to experience them? A way to actually listen to their invisible echoes, just using radio.
So yeah, we all know what they look like, but can you hear one? Well, the answer is kind of yes, but not with your ears. We're going to dive into how you can tune in and detect the secret radio echoes these meteors leave behind as they zip through our atmosphere.
You see, a meteor is so much more than that little flash of light. For every single one you manage to see, there are literally thousands of others, tiny little bits of space dust, burning up completely unseen. But here's the cool part. Every single one of them, visible or not, leaves behind a hidden trace high above our heads.
This trail, it's like a temporary signature written into the upper atmosphere. It's a story told with physics, happening miles and miles up. And it's a story that we can actually read if we just have the right kind of tools.
So how in the world does this work? It feels like magic, but it's actually a really fascinating bit of science called meteor scatter. Let's break down the trick that makes this whole thing possible.
Okay, so as a meteor just blazes through the atmosphere, way up there between 85 and 105 kilometers, it's moving so fast it actually rips electrons from the air molecules around it. This creates this invisible, electrically charged column of air. It's called an ionization trail, and this is the secret sauce. This is what we're looking for.
The easiest way to picture this ionization trail is to think of it as a giant, but totally temporary mirror in the sky. It usually only lasts for a second, maybe two, but that's just long enough for it to do something really important: reflect radio waves.
Now, we're not using something called backscatter, where a signal would just bounce straight back to where it came from. Nope, we're using forward scatter. This means we have a big, powerful radio transmitter in one place, and our receiver, our listening station, hundreds of kilometers away, perfectly placed to catch a signal that bounces off that temporary meteor mirror.
I know what you're probably thinking right now. This sounds amazing, but you must need a giant radio telescope and a lab coat to pull this off, right? Well, what if I told you that you could build a receiver to do this yourself for less than the cost of a large pizza?
That's right, you heard me. Let's talk about the ridiculously affordable little piece of tech that makes this whole project something that literally anyone can do.
$15. That's it. Let that sink in for a second. That's all it costs to get started detecting meteors with radio waves from your own home.
And this little guy is the hero of our story. It's called an RTL-SDR. It's just a cheap little USB stick that was originally made so you could watch digital TV on your computer. But then, some really clever radio hobbyists discovered it could be hacked and repurposed into an incredibly powerful do-anything software-defined radio.
The main thing to know here is that this isn't some rare, exotic piece of hardware. It's built on standard, mass-produced computer chips. You just plug it into the USB port on pretty much any computer, heck, even a tiny Raspberry Pi, and you are ready to listen to the sky.
So you've got your $15 dongle. How do you actually turn it from a piece of plastic into a full-blown meteor detector? Well, the setup is actually way simpler than you'd think. Seriously, this is it. You take a basic outdoor TV antenna and point it up at the sky. That cable runs into your little RTL-SDR dongle, which is plugged into your computer. And that's it for hardware. The rest is all handled by free software. That is your entire receiving station.
Now, what are we actually listening for? Well, you have to be tuned to the right station, so to speak. If you go below 30 megahertz, the Earth's own ionosphere just creates too much noise. It masks everything. If you go too high, say above 150 megahertz, the meteor echoes become really faint and short. The sweet spot, the absolute Goldilocks zone for this, is right there between 40 and 70 megahertz.
Right, so for this whole forward scatter thing to work, we need a really powerful, constant radio signal to bounce off of. And it just so happens there's this absolute beast of an analog TV station up in Canada. It's pumping out a 100,000-watt signal that's so strong it can be used for meteor detection across more than half of the entire United States. Pretty incredible, right?
Okay, so the hardware is all hooked up. We know what frequency to tune to, so how do we turn those invisible radio waves into something we can actually see and, get excited about?
This is where the real magic happens, right on your computer screen. It takes two different pieces of free software working as a team. The first one, called SDR Sharp, is basically your radio tuner, and the second one, Argo, is our visualizer.
First things first, use SDR Sharp to tune your little dongle to that Canadian TV station's frequency. 55.25 megahertz. Now, you're way too far away to actually hear or see the TV show, so all you should get is static. And that's perfect. The software is just sitting there, listening to that static, waiting for that split second when a Meteor echo punches through.
And here it is. This is the payoff. ARGo takes that audio static from the other program and turns it into a scrolling graph, like a waterfall of data. And when a Meteor's trail reflects that TV signal all the way to your antenna, that quick burst of energy shows up on your screen as a bright, sharp, vertical line, a ping. That's it. You are now seeing the radio echo of a shooting star.
And look, don't just take my word for it. Cyprian Sufici, the guy who wrote the guide for this, puts it himself. This is a project that anyone can complete in a weekend on a very low budget.
And this is really just the starting line. Once you're detecting these pings, you have a genuine scientific instrument on your hands. You can count meteor activity 24/7, even when it's cloudy. You can analyze the signals to figure out a meteor's speed. You can even track the activity of huge meteor showers, like the Perseids or the Geminids, right from your desk.
You know, what's so cool about this is that a remarkably simple, cheap setup opens a window to a phenomenon that is completely invisible to our eyes. It really makes you wonder, doesn't it? If a $15 dongle can let us listen to shooting stars, what other invisible stories is the sky telling, just waiting for us to find a new way to listen?